Let's graph y equals 3 times 2 to the exponent x minus 1. So we have a vertical stretch of 3. Again, our base number is 2. So we have y equals 2 to the x that we're going to get our table from. So again, you're going to fill in the y value. So 2 to the negative 2 is a quarter. 2 to the negative 1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 1. 2 squared is 4. Now we're going to make a new table. And we've got a vertical stretch of 3. So we're going to have 3y. And then this is shifted right 1. We can either just move it all right 1 after we graph this, or we can add 1 to here. Since there's no fractions in here, maybe that's not a bad idea, and then we don't have to graph it twice. So we can just add 1 quite easily to the x values and try that. Multiply these by 3, the y values. So we're going to multiply those. When we're graphing 3 over 2, we're going to think of 1.5, 3, 6, and 12. So let's plot this. Again, I need my scale in here. So we'll use 1 and 1. So negative 1 and 3/4. 0 is at 1.5. 1 and 3. 2 and 6 is probably still worth just plotting up here. So 4, 5, 6 would be right here. Because we went off the grid, we want to label that. So you can do that when you go off the grid. I'm not going to plot 3 and 12. That's too far up. I've got enough points here to show how the graph continues. You're still going to have your horizontal asymptote at y equals 0. Again, that means that there is no x-intercept. And the y-intercept we can see on the graph is at 1.5. We plotted that point, so that's why I know it's exactly that. If I didn't plot that point and I see it's in between and I wasn't sure, I could still find it algebraically like so. So you can plug in 0 for x, so y equals 3 times 2 to the negative 1. Y equals 3 times, so 2 to the negative 1 is 1/2. So you get your 3 over 2 that way, which confirms our y-intercept.